why does unit conversion work? Why were we allowed to do this? Well, the reason is, remember that this was an equivalency. 1 kilogram is the same as 1,000 grams. 1 kilogram is the same as 1,000 grams, which means that this is just this whole fraction is really just the number 1, right? It's like 5 over 5. The top here is the same as the bottom. So we're just multiplying by the number 1. Well, it's always legal to multiply by the number 1. Multiplying by the number 1 doesn't change anything. It just changes the form of the number. So this number is the same as this number. It's just in a different form, different units. That's why we have to use an equivalency. We have to put something on the top that's equivalent to what's on the bottom so that we're really just multiplying by the number 1. What would this be as a decimal? Write that out as a decimal without the scientific notation. What do you think? Yeah, here's how you can tell. Well, where is the decimal point in this number? I didn't write a decimal point, which means the decimal point is really here, right? If you don't write a decimal point, that really means there's a decimal point to the right of the number. For example, if I give you the number 5, that really means 5 point. The decimal point is there. Now, I think that you saw that we had to move the decimal point to the left. You saw that we had to move the decimal point to the left, but how many places do we have to move it to the left? 3. That's what this exponent tells us. Well, we just have to be careful of that. 1, 2, 3. Now, it was easy to make the first move, but when we made the second move, we have to put in a placeholder, because otherwise we're not really moving anywhere. And here we had to put in a placeholder. So we got that your second answer was correct. There's 2 decimal places before the 8. It's totally optional whether you put this 0 here. Your calculator would say 0.008, but that doesn't matter whether you put that 0 in or not. I tend to leave it out just to make things simpler. But the key thing is you don't want to have 3 zeros to the right of the decimal point. All right. Well, it's good that you knew that we had to move the decimal point to the left, and it's not too hard to see how many times because this exponent tells us how many times to move. So why was it that originally we wrote this? Why do people make that mistake all the time? Well, they think that this tells you how many zeros to put in. But this doesn't tell you how many zeros to put in. It tells you how many times to move the decimal point. And we only started to need to put in zeros after the first move. It was only after the first move that we had to start putting in the zeros. All right, well, that's worth taking some time on because scientific notation comes up all the time when we're working with chemistry. So we don't want to be totally reliant on our calculator. We want to have a feel for what this means. All right, so your calculator said that that was 8 times 10 to the negative 3, but we could just as well say that it's 0.008 kilograms. All right. Now, remember that there's more than one way you can do this. So to review, I need to put grams of carbon down here, kilograms of carbon up here. Now, I didn't have to use this equivalency. I could use any of the equivalencies. For example, I could use this equivalency. So if I use this equivalency, what number would I put on the top? Because 10 to the minus 3 goes with kilograms here. And what number do I put on the bottom? Well, I can put 1, because 1 goes with grams here. Let's check that on your calculator. Let's see what you get. Oh, well, obviously, we're going to get 8 times 10 to the negative 3. Obviously, we're going to get 8 times 10 to the negative 3. So that confirms that we'll get the same answer, regardless of which way we do it. So again, you can use any of these equivalencies you want, because they all come out to be multiplying by 1, so whichever is convenient. But the helpful thing is to write the equivalency first, because the biggest mistake is putting the 1,000 in the wrong place. Okay. So let's review the systematic method for unit conversion. Systematic method for unit conversion is first, write the starting units. Write the starting units, then write your target units. So a lot of people skip this, but we should actually write the starting units. Write the starting units on the left side of the piece of paper, and write the target units on the right side of the piece of paper, because you want to go from one to the other. Okay, good. And then we have to put in conversion ratios, which are just fractions. In order to do this, the first thing that you do is you write down what units go down here. It should be obvious what units go down here, because we want these units to cancel. And then you write the units that you need on the top. And that should be obvious too, because you want to put your target units up there, if you can. Then you have to put some numbers in. Where do you get the numbers from? From an equivalency. So if you haven't done so already, you have to go off to the side and write down the equivalency. You have to make sure you write down the equivalency correctly, because it's easy to put the number on the wrong side. And then when you have that equivalency, you know where to put the numbers in here. All right, and then you can just work it out on your calculator and get the answer. Okay, now where do we get the equivalencies from? Well, some of the equivalencies you just already know. For example, I think you kind of already knew that there was 1,000 grams in a kilogram. You just had to be careful and work that out. Do you know what's the equivalency between inches and feet? You know what the equivalency is between that? Actually, these are not metric units, so maybe I shouldn't work with this. So I guess these are really just used in America now, 12 inches in a foot. So maybe this is not too important for science, so we won't be worried about that. Let's try this one. I could ask you, say, what's the equivalency between minutes and hours?
60.
But where do I put the 60?
60 minutes is 1 hour.
Right. It would be a big mistake to say 60 hours is a minute, so you have to put that in the right place. How about if we have minutes and seconds?
360 seconds is 1 hour, so 60 seconds is 1 minute.
60 seconds in a minute. Good. So now the 60 goes over here. Good. How about kilometers? Wow. And meters.
1,000 meters is 1 kilometer.
We kind of already did that up here. Kilo always means 1,000, no matter where it is. So if you know that there's 1,000 grams in a kilogram, you know there's 1,000 meters in a kilometer. How about centimeters and meters?
100 centimeters is 1 meter.
Okay, so a lot of the equivalencies you would already know. However, many of the equivalencies you might not know, and you have to look those up. So if you have a textbook, on the back cover of the textbook, they have a lot of the equivalencies that you need. So these are all equivalencies that might come up. So for example, see if you can find the equivalency between miles and feet.
1 mile is 5,280 feet.
Right. 1 mile is 5,280 feet. Good. All right. So very good. What's the equivalency between pounds and kilograms?
1 pound is 453. Oh no, 1 pound is 0.45359 kilogram. 0.45359.
Good. 1 pound is 0.45. Okay, that's not something you would be expected to have memorized. You can just look that up. All right, so we can look that equivalency up.